Welcome to a lesson on 10.3, graphing cube root of functions. This is a continuation from graphing of square root functions. In many ways, our approach will be very similar with some minor differences. Here we're dealing with odd degree polynomial. Here the domain and range is all real numbers, right? And right off the bat, it's right in the cube root of parent function, we notice that the x values are allowed to be negative. The question is, why? Well, the relationship is that y cubed is equal to x, right? So if you could cube this number, is there a number that you could cube here that will yield -8? And the answer is -2, right? Yes, that's the reason why it could be negative. Because when you cube a negative value, its output is negative. So plugging -8 into the cube root of 3, it gives you -2. So why don't you go ahead and plug in the rest and see what you get. Pause the video to do that. Now once you've done it, these are the values you have. As before, we would plot them on the graph, and that's what we get. And we'd simply connect this way and this way. When you do that, we end up with this. Once again, I apologize. I don't know how to put a arrow on a Desmos. So, but there, even though it doesn't show it, there is an arrow at the end. Okay. So if you look at this, this looks awfully close to y equal to x cubed, right? Cubic function, except the roles of the x and y were reversed, and that's exactly what it is. Moving on to graphing cubic root functions, as we've done it in the past, we are just simply reminding you of the role of the h, k, and then a and b. The role that it plays is exactly the same. K is a vertical translation, up or down, and h over here is a horizontal translation, or shift, left and right, and so on and so forth. And a is a vertical stretch compression. Depending on the value, it's a stretch. If the absolute value of a is bigger than 1, it's a stretch. If the absolute value of the a is less than 1, it's a compression. Similarly, for the b. Looking at this example, what are the values of a, h, and k? If you said 2, 3, and 5, you're correct. Now, I gave you this point. You should probably include this, plot this points on the graph that was provided for you. -8, 2, -1, 1, 0, 0, and 1, 1, and 8, 2. Those are my anchor points. The formula that we're going to be using to do the conversion, without having to go through it one at a time, is x plus h, comma, a times y plus k. Why is that? Okay, first of all, the shift of hk is added to x and y value. But before we could do that, we have a here, which is a vertical stretch. We must apply that to the y coordinate. See that? We do that before we do the shift. So that's hence the formula for the y coordinate becomes ay plus k. Okay? All right, guys. I'll explain a little bit deeper in class and a little slower. Okay? So if you plug in xy into this formula, you should have gotten -5, 1. Why don't you pause the video and plug in the rest of the values? So we're back. If you did that, these are the values that you should have gotten, and plug those in. Do you see this 0, 0? This origin? With a shift 3, 5, that right there, 0, 0 became 3, 5 right there. And if you connect the rest of the points, it looks like this. Once again, there's an arrow at the end that I don't know how to do on Desmos. Okay? All right, so this represents both the shift of 3, 5 and the vertical stretch of 2. Okay? Very similar to what we did, right? Okay, guys, there are a few more. This one, and this one that we'll be doing in class. So if you'd like to sort of think about it a little bit more, great. If not, we're going to do it in class. Okay? All right, guys. Have a good night.